What is it?
This, Jen, is the internet.
What?
That's right.
This is the internet. The whole internet.
Yep. I asked for a loan of it so that you could use it in your speech.
It's so small.
That's one of the surprising things about it.
Hang on. It doesn't have any wires or anything.
It's wireless.
All right, ladies and gentlemen, welcome to Introduction to Networks, Cisco, Module 1. My name is Mr. Tandy. I will be taking you through Module 1 here in our Cisco class here. And the reason why I played that video, the reason why I played that video, because if you notice at the very, very end, she says, so it's actually a pretty funny clip. She says there's no wires, there's nothing attached to it, and he responded that it's wireless. Okay, well, everybody sees the internet as the internet, but they don't understand how. Some people don't understand how they get that data to their devices, right? They don't understand where it comes from. So the networking is basically the backbone to how those end devices get that internet, right? That does those misconceptions. Oh, I can just get on the internet. Okay, well, how does your data actually get there, right? How'd you get there? So this class is going to go through a lot of that. We're going to get through the module right now, so we're going to do module 1 here. So, yeah, here we go. Let's just kind of get into it. All right. So, network affects our lives, right? This is kind of the things we're going to get through. Some of the topics: network components, network representations, as you can see here on the screen. Okay. We're going to explain how networks affect our daily lives. We're going to explain how a host and a network devices are used. We're going to explain the network representations and how they are used in network topologies. Okay. We're going to compare, contrast the common types of networks. We're going to explain how local area networks, LANs and WANs interconnect to the internet. Right. There's the networking, right? Internet there. Describe the 4 basic requirements, reliable networks. Explain how trends such as BYOD, which is basically bring your own device, online collaboration, video, cloud computing, changing the way that we interact. Network security, we're going to identify some basic security threats and solutions for all networks. Explain employment opportunities towards at the end, because there's a lot of jobs, a lot of cool businesses that are looking to hire. Right, this is a very, very lucrative field right now. Cybersecurity, networking, all that good stuff. The IT business is very, very big, and big businesses want to hire you right now. So let's get into this. Networks affect our lives. Okay, so we got to try to figure how they really affect our lives. Let me see here. Let me make sure I get all my ducks in a row here. Okay, so communication is almost as important to us in our reliance on air, water, food, and shelter, right? In today's world, through the use of networks, we are connected like never before. That is absolutely true. We are absolutely connected. So one thing I like to talk about, I teach my cybersecurity class over at Arlington, is that, we talked about we're connected like never before. If you go back to 1970, the ARPANET, when the big computers, the big supercomputers, universities were talking to each other. That was an awesome way to be able to move data instead of getting into a mail truck and moving things. So now that we're connected, that new idea of being able to get connected, any way they can get onto the network so they can communicate and do things is so amazing now. So that statement of we are connected like never before is absolutely accurate to kind of what we have going on here. So, okay, moving on here. This is our Cisco Network Academy class. A little video. I won't be playing that video. Our boundaries, okay? We absolutely have no boundaries, and when I see this graphic right here, I want you to think of the globe. I want you to think of Earth, okay? I want you to think of Earth. And as a matter of fact, I think I have a copy right here. So take a look at this. I want you to think when something has no boundaries. So if I were to take this globe and spin it, right? If I continue spinning, if I started in one spot and keep going, you will see that I will pretty much end up in the same spot as I started, right? But there's no boundaries. It's infinite, right? This is what I call our cyberspace. This is our cyberspace, right? No boundaries. Cyberspace has no boundaries. The global communities, all of our human networks, all evolve around our Earth and our cyberspace here, right? So all of our infrastructures on how they built all of our infrastructure, technology, how things move, right? It's all through our cyberspace. So very, very, very important per se. So yeah, a world without boundaries, global communities, and our human network. Okay. Let's keep going here. So network components. Let's get into the components of a network, right? Because we have to be able to use a device to see when that data shows up, right? You know, one thing that's very fascinating to me when it comes to networking is I've been in information technology business for about 7 years. I was an information support specialist for 7 years or so at a school district, and you know, one thing that was very, very awesome for me to understand was the fact on how the data moves, right? You know, when you're looking at a computer, when you double click on a web client, where does that go? Who's hosting it? What's the server? Who's the one that has that information that actually makes that information show up? What moves that data? What devices are able to move those packets and things of that nature? So that's always been fascinating to me, being able to understand. And then moving forward, I want you all to understand as well that you're going to hear me refer to a lot of items in these modules about that mail truck. Okay, we all know what we do around Christmas time, right? What do we typically do during Christmas time? We're always, you know, if we're going to shop on Amazon and we're going to order something and maybe we're going to send it in the mail, okay? Well, in order for it to go into the mail, right, before it gets to its destination, that physical package needs to go into a box, right? And as soon as it goes into the box, you address it and you need to send it into the mail. If you go to your local mailbox, who typically shows up, right? That mail truck or that UPS truck that sends that data out, and then it gets to its destination, whoever it needs to get to. And then when they get it, they look at it and they're presented with the data. Internet works the absolute same way, but it happens in a matter of seconds when you double click on a couple items, which is super cool. So let's kind of keep going here. All right, kind of get through these items here. All right, sorry about that. All right. So, host rules. Okay, every computer on the network is called a host or a end device. Okay, so Cisco is very, very big on these items, making sure we understand the difference between a host, okay, basically a host and intermediary device, which we'll be getting into, which is the stuff that actually moves the data. So, servers are computers that provide information to end devices, email servers, web servers, file servers, okay. Clients are computers that send requests to the servers to retrieve information. So let's kind of break that down. Clients are computers that send requests to the servers to retrieve the information. So that's essentially taking that, you know, if you were on a computer and I double click, my client is a host, so I'm using my machine, right? I double click on that computer, right? And that's my request. There has to be a server that's going to give me that information, give it back to me, right? So that's essentially kind of looking at that. That's kind of what that is there. So let's kind of go back into this here a little bit more. Clients are computers that send requests to servers, web page from web server. Okay, we got that good stuff. Email, right? Email server runs email server software. Clients use client software to access email. Web server runs web server software. Clients use browser software to access the web pages. So it's getting onto the internet, or getting onto website, if you want to take a look at some of your cool websites. And then the file server, which basically works as a way to organize your files or where there's a lot of information and data. Now, before we get going, I just want to kind of make sure we understand a little bit more. When it comes to this word here, okay, I'm just going to kind of highlight this here. This here, a server, okay? a server. Now, everybody think, let's just think, for example, actually, I'm sorry, let me get out of this for a quick second. All right. When it comes to a server, I want you to think of your favorite restaurant, right? When you go to that restaurant, what typically happens when you show up? The host is there, asks you how many in your party, cool, no problem, and you go sit down, right? As soon as you sit down, the host there will give you your menus and all that good stuff, and you leave. After that, who shows up, right? Who shows up? Person that shows up is the waiter or the server, right? The server. Okay, so you sit down and you order some food, drinks, and all that good stuff. What typically does that server do? Server will go back, feed that request, right, to the kitchen or whoever's there, which is like another server, right? And then that server brings that information, excuse me, getting into IT stuff. That server brings the food or drinks back out to you, okay? Brings that stuff back out to you. That's essentially kind of what's going on here, right? So here's the server, okay? Here's the server. So I'm just going to do it. Here's the server, all right? And we are the client, right? Okay. And we're sitting down at the table. And I'm a bad artist, okay? I actually don't know what that is, but it's okay. We're sitting down at the table, and then the server shows up and says, hey, what do you need, right? And actually, we draw some more stick figures here. This is pretty cool. Wasn't always an art person. But anyway, the server takes our order, right? In this case, we're the client. And the server says, hey, what can we use for, what do you need? Cool. I'd like to have some drinks and all that good stuff. So the server literally just kind of walks over here via the internet, grabs information, grabs the drinks, and comes back and gives us our information, right? So that's kind of a little snippet of kind of what that kind of looks like there, right? So that's kind of where we're going to get into a lot of that there. Let's see here. Peer-to-peer, okay? Peer-to-peer. It is possible to have a device be a client and a server in a peer-to-peer network. This type of design is only recommended for very, very small networks, okay? So, for example, it says here, I have a printer to share, I have files to share. So if you take a look at this, obviously all of these two clients here, these hosts, are essentially sharing the same cable, right? They're on the same network. So they obviously can send information to each other, which is awesome for peer-to-peer. Yeah, some of the advantages, they're easy to set up, no centralized administration, it's not as secure, right? And then it has obviously a little bit lower cost. Now, let's get into end devices, okay? So we have hosts, clients, we also have end devices, because end devices are also hosts as well, okay? So if you take a look at this picture, an end device is where a message originates from, right? Or a message originates from, and where it is received. Data originates from an end device, flows through the network and arrives at the end device. So let's take a look at this graphic here. Okay, let's take a look at this graphic, and we're going to go back to that mail truck. Remember, I told you about that mail truck. So let's say, for example, you're sitting here at this computer, right? This is you at this computer, and you want to send some mail out to your buddy that's maybe out here in, let's say, the state of Texas. I just threw Texas out there because I know they have some really good barbecue. So let's say you want to send your buddy some information. Let's say you want to send him a package, right? You want to mail him something, right? You are going to address it, right? You're going to send it out in the mail, and it's going to hit a little post office, right? So this is an intermediary switch. Okay, we're going to get into that. We'll talk about intermediary devices here in a minute. Okay, so essentially, you go out to your mailbox, and it goes out. Okay, so the little mail truck shows up, right? And that is a bad mail truck, but it's okay. So your mail truck shows up and it delivers it and it goes to the big hub. Okay. At the hub, there is multiple trucks, right? There's multiple trucks that are there. Okay. We just call those trucks. Now, if you take a look at this, we're going to call this little device here, we're going to call this a hub, which essentially is a router. Okay. Think of the word router. It actually routes the information, right? A router, you send it to it and it routes to different locations as it needs to go to, right? Okay. So what's going to happen is, put this back up here, the router is going to should know where to go, but there's different links and different ways the truck can go to get to its end device here, right? So that router is going to send that information. Okay, excuse me, you're going to send the information out. The mail truck's going to show up. It's going to hit the router. It may hit another router here somewhere, and then now we said Texas. I forgot to give. This is California. We'll call this Cali. It may hit a router somewhere, maybe in Arizona, right? It may shift trucks, or somewhere maybe New Mexico, something like that. And after a while, these two routers, they're going to talk to each other. They're going to know, these hubs are going to know, hey, how do I get to Texas? Cool, no problem. It's going to say, hey, take this road to get there. And then eventually it shows up. So here, again, flows through the network and arrives at the end devices. Okay, data originates from the end device. So the original data, right, for this person to get this information, he's got to send it out to mail truck picks it up, and then they eventually get the information. Folks, data moves the absolute same way, right? That's how our data moves the same way using those mail trucks. Like I said, we're going to talk about those a lot. Intermediary devices, network devices. An intermediary device interconnects end devices. Examples include switches, wireless access points, routers, and firewalls. So very, very important. Make sure we understand these two, okay? Actually, we'll get out of that here in a second. So Cisco sees end devices as, let's go back to here, like servers, the client, which are the computers. Those are the end devices, right? Those are the things that are handling this. These are the information. That's the information that you want to see, right? So those are the hosts, right? Those are the end devices. Cisco calls intermediary devices basically those routers, those switches. These are the things that move the data, okay? These are the things that absolutely move the data to where it needs to go, right? So management of data as it flows through the network. It also is the role of the intermediary device, including regenerate and retransmit data signals. Interesting, right? Maintain information about what pathways exist. There, I did use that word, right? Pathways. In this example, we talked about how these different routers know the different path, right, to get there. This is like the, I think I used the example of UPS. These are the UPS hubs that know which route to take, right? Okay, intermediary devices. Maintain information about the pathways, all that. Notify other devices of errors or communications and failures, okay? So that's kind of what Cisco calls these intermediary devices, all right? So continuing here. Now, with the intermediary devices, we have to have those cables. Something's got to be hooked up to move it, right? Something's got to be able to connect all of these devices together. So, for example, if we go back to this, and I love going back to this graphic, okay? These little roads here, okay? There's something that has to connect there, right? There's no way for this data to move without it physically going through something, right? There's got to be some type of connection in order for person A to get person B information, right? And basically what that is used for is network media, okay? So there are different types of network media out there. We have copper, fiber optic, we have wireless ways to move things. Communication across networks carried through medium, which allows a message to travel from source to destination. Very good. Metal wires within the cables uses electrical impulses. Glasses or plastic fibers use pulse light. That's basically those fibers because they use lights. And then wireless transmissions use modulations of specific frequencies of electromagnetic waves. Now, just to ensure that you are watching this video, I'm going to write something on my screen here, and I want you to tell me, just send me a little email on what this is. What am I doing here? This is how computers talk to each other. So send me an email and let me know if you know what that is right there. All right, moving on. All right, so network representation and topologies. Okay, this is also big, right? How does that data move? How is everything set up, right? When we're going to go back to the mail truck, okay? When you get ready to send something in the mail, okay? How is the structure, right? How is everything set up? How is everything supposed to look? What is everything supposed to look like, right? So let's take a look at that. Network representation. Network diagrams, often called topology diagrams, use symbols to represent the devices within the network. Okay. So this is a good example here. In devices, these are desktop computers, laptops, printers, telepresence endpoints, wireless tablets, and a IP phone. Right. Important terms to know: network interface card, or a NIC. Right. Network interface card, physical port, and interface. These are intermediary devices. This is what actually handles the data. So when you look at this graphic, okay, we're going to look at this graphic a lot, and you're going to need to know these a lot when we get into Cisco Packet Tracer. Okay, that's a big one. I want you to think of these end devices. Okay, I want you to think of the end devices as trucks that show up at your house to move your data. Okay? These are the trucks. Okay? The intermediary devices, these are basically the hubs, right? These are the hubs. So when requests get sent out or they receive requests, okay, there's typically going to be a truck, right? There's going to be a truck that is going to move, and we can also add an airplane too. So let me draw a little picture of a plane too. Let me just, in case it's like somebody wants to send airmail or anything of that nature. But for the purpose of this, we're going to use the truck. So when the truck sends that information, it's going to hit intermediary devices, and these are the hubs, right? So the truck is going to go through these little hubs to send the information out. Now, when we get to the network media, I want you to think of this as the roads that the trucks use, okay? I want you to think of this as the roads. This is the wireless media, the local area network medias. That's basically all of this, what we were talking about, right? That is, let me go back here. So that is this information here, right? Uh-oh, sorry. Let me go forward. Oop, I am all messed up here. Let me go back, apologize. That are these cables, right? This is what moves our data. These are the roads. This is very, very important, right? Without these roads, without these intermediary switches, okay, that these roads plug into, we can't have the internet, right? There is no internet, okay? Let me repeat that. There is no internet, right? We need to have, with exception of satellite, we need to have these intermediary roads, right? We need to have the stuff. We need to have the mail trucks, right? But we need to have these roads in order to move that data. So very, very important. Okay, very important. So let me put that back up there again and see if that shows up. Okay, so the hubs, okay, this is basically the truck hubs, right? Make sure we get that there. And then the roads. This is the media. This is the roads that the trucks take, and these are all the different trucks, right? So that's a good way to kind of take a look at those items there. All right, let's go to the next one here. These are different topology diagrams. Physical topology diagrams illustrate the physical location of intermediary devices and cable installations. Okay, so this is essentially how everything looks. Okay, let's go to this side. Logical topology diagrams illustrate devices, ports, and addressing schemes of network. Okay, so when you're looking at this stuff, when you're looking at these devices, you know, here are all of the, let me put my pen back out here again. Let's erase that. Here are all of the end devices, right? These are the end devices, end device, right? End device, okay? And here, let's pick a different color. These are the intermediary devices, right? Here's the router, the switches, right? Okay. And then that network media, right? The media that moves it. That's what these are. Okay. Once again, end devices, this is the trucks that moves the data. These are the roads on how to get to the data, right? And then obviously we see internet. So when we look at topology diagrams, is basically topology refers to in networking how it logically looks, right? How it looks if you were to go to the different areas, right? The way the data moves, how you can see it in your brain per se. That's kind of gives you an idea on what that looks like there. Now let's go to the next one. Common types of networks. Okay, because we definitely have different types of networks that are out there, and we got to know the different types of out there. Excuse me, got to know the different types of networks that are available out there. Oh, sorry about that. All right, so getting used to this OBS stuff is pretty cool. So we have many sizes of networks. We have small home, SOHO, small office, home office, okay? Medium, large networks, and we have the World Wide Web, okay? So small home networks connect a few computers to each other and the internet. So that's probably kind of what's maybe at your home, right? Small office, home office, or known as a SOHO, right? Enables computers within a home to remote office to connect to a corporate network, okay? Medium to large networks, many locations with hundreds of thousands of interconnected computers. So this is essentially like those big buildings you may pass on the freeway. Okay, that's pretty much like a medium to large network. And then we have the World Wide Web, right? This is how all of them are all connected, right? Those are all the different sizes of networks, right? Again, going back to that video, the internet, and the lady says, well, there's no wires, anything like that. That's because, obviously because of the skit, the networking is what gets that internet, right? That's what allows us to have our data and which moves and things of that nature, which is pretty cool. LANs and WANs, okay? So local area networks and wide area networks, okay? Network infrastructures vary greatly in terms, size of the covered area, number of users connected, number of types of services available, area responsibility. Okay, so local area networks typically means that it's two or more clients on a system, right? That's a local area network, two or more, right? Wide area network is essentially when you connect all of the LANs together, right? That's kind of a wide area network. I like to view it as typically like a metropolitan area network, right? Metropolitan area network. So let me give you a representation of that. Give me 1 second here. Let me see if I can pull this up. Picture of the United States here. And United States. All right, so if I were to look at this picture, right, let's see if I can pull this up here. Here we go. So looking at the U.S. here, right, if we're looking at the United States, local area networks are essentially the areas, like this is your homes, right? Your houses are here, okay? All these little dots represent small little local area networks, right? And then within these local area networks are big cities, and when you connect them all together, you have essentially your metropolitan area network, right? Or you call it a MAN. The wide area network, okay, I'm just going to put these little dots on these other little areas, okay? The wide area network essentially is the internet, right? That's all of these all connected, right? These are all the little roads that are connected to each other with physical mediums. Now, I could draw a little bit more, but I think you kind of get the idea of kind of what we're looking at there. That's kind of, give the real representation of what they're kind of referring to. So two of the most common types, as it talks about, is the local area network and the wide area network, okay? local area network and wide area network. We will talk a little bit more about the cloud as we get more into the networking. A LAN is a network of infrastructure that spans a small geographical area. Okay. Wide area network infrastructure that spans a wide geographical area. Okay. So wide geographical area. I just think of geography, right? It's the land, right? The whole United States. That's more the wide area network, or known as the World Wide Web or the internet, right? That's kind of what those are. Interconnected end devices is limited, administered by a single organization, individual. This is for LANs, provide high-speed bandwidth to internal devices. WAN is interconnected LANs. That's what we talked about. That's all the LANs and MANs that are all together, typically administered by one or more service providers, ISPs, internet service providers, all that good stuff, and typically provide slower speeds, links between local area networks. The internet. Here we go. The internet. Let's go back to the box, right? The internet. The internet is a worldwide collection of interconnected LANs and WANs. That is correct, right? LANs are connected to each other using WANs, okay? And then WANs may use copper wires, fiber optic cables, wireless transmissions, right? Because when you get into the WAN, wide area networks, there has to be those media devices to be able to move that stuff, right, to those big areas, right? The internet is not owned by any individual, right, or group. The following groups are developed to maintain a structure: this IETF, the ICANN, and the IAB. Now, this is pretty cool because Cisco, the way Cisco talks about the internet, there's some little subcategories in there as well, which Cisco kind of gets into. So let's get into those. The internet is a private collection of local area networks and WANs, right? Internal to an organization that is meant to be accessible only to the organization members and others with authorization. Okay, with authorization. The organization might use a extranet, okay, to provide secure access to their network for individuals who work with different organizations that need access to their data on the network. Okay, so that's essentially, okay, we have the intranet, right? Only internal individuals can have access to this. Take a look at this graphic, right? Nobody on the outside world can get it. Then you have the extranet. Certain suppliers can have access to things. Organizations might use extranet to provide secure access to the network. I'm not sure if you guys are up to date on the cybersecurity stuff, but I know with the Target hack, when they hit the HVAC system, if I remember correctly, I believe there was an outside company that had access to the HVAC system. They pretty much used the extranet, but they were able to get into the internet and steal a bunch of data, which was not good. Okay, and then we have the internet, which is the world there. All right. Now, internet connections, right? We got to be able to connect, right? We got to know how these connections work so that data can move, right? We need to know what type of mail truck shows up. Is it an EV? Does it use gas? Does it use electricity? We don't know, right? Those are the things we have to kind of take a look at here. So there are many ways to connect users to organizations to the internet. Popular services for home users use small offices include broadband cable, broadband digital subscriber line, DSL, which is slow, wireless, wide area networks, and mobile services. Okay. Organizations need faster connections to support IP phones, video conferencing, and data center storage. Now, why do you think that's important? If you look at that, organizations need faster connections. Why would you think that would be important? That is your question. Email me your answers to that. Why is it important for organizations to have faster connections? Okay, I need to see your email on that one. So business class interconnections are usually provided by service providers and may include business, DSL, lease lines, and metro internet. So let's move it on here. All right, so internet connections, home and small office internet connections, right? Cable, high bandwidth, always on internet is offered by cable television or service providers. Now, more than likely, okay, I don't know this for sure, but your home may have a cable, a white cable coming from the street. In fact, I have Spectrum, so I have a white cable, which goes into a modem, right, which gives me that, goes from analog to the digital signal. So that's typically what's in the homes. nowadays, right? DSL, may high bandwidth, always on internet connection that runs over the telephone lines, okay? Cellular, we all use our phones, right? If we don't have Wi-Fi, we're using those cell services in order to get connected, right? Satellite, major benefit to rural areas without internet service providers, right? Satellite. Now, when I think of satellites, let me just kind of give you a quick little observation. I don't know if anybody's ever been through the state of Utah, but I traveled through Utah, and going through Utah, there was obviously a lot of rural areas there in that state, and going up to 15 freeway, I remember seeing a house way at the top, bunch of houses like way away from the freeway, isolated all by themselves, like a big farm outside. And I often wondered, how in the heck are they getting internet, right? How is that? How are those roads being connected out there, right? How are they getting any fiber connections or anything of that nature? More than likely, they're probably using some type of satellite or maybe some cellular too, right? That's the only way they're able to get the internet information out there. So I thought that was pretty cool. Business internet connections, okay? Dedicated lease lines, those are private. Those are reserved circuits within the service providers networks that connect distant offices with private voice and data networking, okay? Dedicated lease lines. So I want you to think of this as like this is basically, these are lines that are owned by corporations. Nobody's allowed to get on those, not even us, right? These are all big business lines. People pay big money for those. I'm going to put a big money sign right there. Big money for those lease lines, right? Big money. And then, Metro Internet extends local area network technologies into the wide area networks, right? Ethernet, Metro Ethernet. Use a lot of Ethernet cables, right? That's what we're using with that RJ45 connection on the end of them. And business DSL and then satellites. So if you take a look at this, right? These are these big organizations. These are ways that they can get their data, right? These are the bunch of end devices in here. These are the roads. The truck moves and back to the end device and all that good stuff, right? Okay. Converging networks. Okay, so before converged networks, the organization would have been separately cabled by telephones, video, and data. Each of these networks would use different technologies to carry the signal, right? Each of these technologies would use a different set of rules and standards, right? Different protocols. You can hear me say that word a lot. Protocols. Oh, and by the way, when you hear me say the word protocols, you'll see this. We'll talk about this in the future, but when we get to just a computer, computers are dumb, right? Computers need protocols in order to do something. Protocols are basically a set of rules that something is supposed to happen. So different set of rules and standards, right? So computer networks, right? These end devices, there's going to be a different set of rules, right? Think of this as, going back to the truck, this is like a EV truck, right? We're going to use the EV truck for this set of rules, right? Okay. For telephone networks, they're going to use maybe the gas truck to move data, right? And then the broadcast networks, they may use, let's say, an airplane, okay? Like an airplane or something, right? That looks like an upside down, like a sideways stick figure. I don't know what I was doing there. But anyway, I think you guys get the idea of, where I'm trying to get at there, right? So the different ways these converge, they all have different rules, different set of rules, different set of protocols, right? Convergent networks, converged data networks carry multiple services on one link, right? Data, voice, and video. Converged networks can deliver data, voice, and video over the same network infrastructure, right? Same infrastructure, right? So when you hear the word infrastructure, I want you to think, and I'm doing my drawing again because I love doing drawing, even though I'm not very good at it. Don't make fun of me. It is what it is. When it says infrastructures, I want you to think of this as everybody's under. Oh, hit the eraser. Sorry. Ooh, what am I doing here? Oh, excuse me. What you think of this as a big house? Notice how all these end devices are in the same house. excuse me again, right? But they're all going to use the same mediums, right? But they all have a different set of rules, right? Whatever the rules are. And this is also another set of houses, right? This is big infrastructure. But they all use the same set of rules. They all have to use this big rule right here. They all have to follow the same standards, right? Protocols might be different as far as getting there, but they also have to, but they do need to follow the same rules. Very, very important. Okay, so download Packet Tracer. Yeah, so you at this point in time, you should have Packet Tracer. Okay, if you don't have Packet Tracer on your computer, I want you to pause this video. Pause video, unpause, right? All that good stuff. Pause video. Make sure you have Packet Tracer. Okay, you gotta have Packet Tracer. So make sure you have Packet Tracer. If you don't know how to download that, I will help you out with that. Okay, I'm gonna get through all this. Now, reliable networks. Okay, sorry about that. Our network architecture. Okay, refers to the technologies that support the infrastructure that moves data across the network. There are 4 basic characteristics that underlying architectures need to address to meet users' expectations. Okay, going back to the CA triad, having availability, right? We have fault tolerance, scalability, how much we can add to it, security, right? And then the quality of service. So let's get into those, right? Fault tolerance, okay? A fault tolerant network limits the impact of failure by limiting the number of affected devices. Multiple paths are required for fault tolerances, okay? Redundant connections. There's that word again, redundant, redundant, redundant. What am I doing right now? I'm being redundant. I keep repeating myself. I'm being redundant, I'm being redundant, I'm being redundant. Redundant again, and also redundant again, right? So I continue to be redundant. Alternate paths, right? These are different paths to get to where it needs to go. So, as we talked about with the local area networks, right? Let's look at these local area networks. So let's say we have local area network 1 and we have number 2. Okay, notice these are all separate. So as soon as that local area network leaves, right, it hits that intermediary device, which is the hubs. Remember we talked about the hubs, and then the different trucks. These are the different roads that it needs to get to. These are all the network media. These are the media connections. So when we talk about redundancy, right, things that are redundant, what would happen if this road were to have construction, right? We live in California, and there is typically construction all over the place, right? There's always construction. So what would happen if this road were to break? Would somebody have access? Would somebody's information still be able to get to the internet? The answer is yes, obviously it would, right? Because of the different multiple paths that it needs to get to. This is the fault tolerance, right? Fault tolerance network limits the impact of a failure. So the end goal is to get out to the internet, to get to that web request, right? We want to get out there. So to limit that, we have multiple redundancy. We have all these routers that are communicating with each other. We have all these different trucks, right? Very, very important there. Scalability. A scalable network can expand quickly and easily to support new users, applications without impacting the performance of services and existing users, right? Additional users and whole networks can be connected, right? Being able to add to a network, right? Being able to have multiple users, right? Things that are scalable. Think of a scale, a weight. Being able to have multiple items, multiple hosts to have access to the network. That's scalability. Quality of service. Now, I'm sure we may have some gamers watching this show, right? Not show, excuse me, the video, not a show, I apologize. We may have some gamers, right? So if you're a video gamer, or if you just like to stream on the internet, have you ever had a situation where your video packets drop out, or you may lag out, right? I have teenage boys. They love playing Fortnite, Overwatch, all those games. And typically when they complain that it's lagging or they get hooked up to a server, it's not working, they lag out, I have to go in there and to my router, and I typically have to adjust this quality of service, right? You know, I got to make sure they get dedicated packets, right? They get dedicated resources so they won't have those breaks and those pauses and things of that nature. Okay. Quality of service is a primary mechanism used to ensure reliability, delivery, and content to all users, right? So when somebody shows up with a big old box of popcorn, right? A whole bunch of popcorn. Who's getting access to the popcorn? People that want that popcorn. We may give a little bit more to Joe because Joe likes more popcorn over Susan or something like that, right? Quality of service. I know it's a bad example, but that's the first thing that came to my mind. Network security. Okay. There are two main types of network security that must be addressed, right? Network infrastructure security, physical security, preventing unauthorized access to devices, right? We don't want people to get access to them, right? Notice login and passwords, right? Cisco is very big on this as well, especially in Cisco Packet Tracer. Teach you how to configure a switch and encrypt the information, encrypt all the passwords, right? When you do the show run config file, when you do the show run command, be making sure that those passwords are encrypted so you can't see them. Very important, right? And then the 3 goals of network security, and this is all part of cybersecurity, and this is typically what I teach at the high school level, is called the CIA triad: confidentiality, integrity, and availability, right? Is it confidential? Is your data confidential, right? Those social security numbers, those bank card statements, right? Those bank card information, that security code on the back, those things of that nature. Is it confidential, right? We want to make sure that's confidential. Integrity: has anybody changed your data, right? Alter your data. We want to make sure that that doesn't happen. And then availability. This is probably the biggest one now with the internet, is the availability. Being able to have access to your data, right? That's the whole purpose of the cloud. That's the whole purpose of redundancy, is people want high availability. High availability. They want to have access to it as much as possible. Network trends, okay? Now, these slides are a little old, but it's okay. It's still relevant to today. The role of the network must adjust and continually transform in order to be able to be able to keep up with the new technologies and end-user devices that are constantly come to the market. So they're always trying to find ways to access the internet. You know, I talk about this a lot at my high school level. There's the introduction of ARPANET, 1970, right? The whole idea of these supercomputers is universities being able to communicate with each other and send data instead of using the actual mail truck, right? The evolution of that, right? They found these awesome ways to be able to talk to each other and communicate with each other and being able to do it in an effective and quick manner, right? But it's changed, right? Now everybody has access to all that right now, right? Everybody wants to get that. Everybody wants to be able to have a piece of the pie to move that data along. That's the high availability piece of it, right? Being able to get to it as quick as possible. So we have, bring your own devices, online collaborations, Zoom, right? Video communications, Zoom, and then cloud computing. Zoom, everybody knew about Zoom as soon as the pandemic hit, right? Everybody was big Zoom fanatics with Zoom, Google Meets and all that good stuff. Zoom was a big one. Bring your own devices. Don't need to get into this too much. Bring your own devices, BYODs, like your laptops. You're probably watching the show. Not show, excuse me. I said show again. You're probably watching the video on your phone or your computer or whatever device that it may be, whatever IoT device, Internet of Things, all that good stuff. Collaboration, again, like Zoom, being able to collaborate, being able to have multiple users connect so you can have awesome things happening, which is pretty cool, those meetings. Again, going back to Zoom, people realize that after the pandemic, all I need is an internet connection. I can sit at home, use my webcam, use these collaboration tools, and be able to collaborate, right? Be able to do things that we would do if we were sitting down physically in person, which is pretty cool, all right? Video communication calls made everyone, regardless where they're located. Got that. Won't get into that too much. Cloud computing. allows to store personal files, backup data on servers over the internet. Applications can be accessed using the cloud. Now, let's talk about the cloud, because this kind of brings me to something that's pretty funny. It's kind of cute, but funny at the same time. In one of my classes, this happened about a year ago, we got into talking about the cloud, your data being stored into the cloud and things of that nature. And I had a student raise their hand and say, Mr. Tandy, are you really talking about the actual clouds outside of our classroom? Our data's literally up in those clouds? And I didn't do that to him, the person, but I was kind of laughing. I was like, no, we're not actually talking about the clouds, but we're actually talking about, where your data is, the cloud, those servers, being able to have access to those data centers that have redundancy, so you have access to your information. That's what we're talking about as far as the cloud is concerned. Cloud computing is made possible by data centers. That's what we're just referring to, right? Smaller companies that can't afford their own data centers lease servers and storage, right? So they let different companies have access to your data, so you can have that redundancy, right? For example, iCloud, right? People that have iPhones. If there's not enough local storage on your phone, right, you use iCloud, right? Or Google Drive. If you're a Google user, use Google Drive. I like Microsoft products. I like to use Microsoft OneDrive, right? Have that redundancy, right, all over the place. I can hop on a plane in California, go all the way to Texas or Florida, hop on a computer, log in, and I still have access to my data, and I'm geographically in a different location, which is pretty cool, right? Pretty cool. Cloud computing, so there's 4 types of different clouds. Cisco talks about public clouds available to the general public through pay-per-use model. That's that Microsoft Office 365 I was referring to, things of that nature, pay-per-use, right? Private clouds intended for specific organizations, right, or entities such as a government, right? Those are private. We don't necessarily want outside people being able to get to that. You have to have authorization in order to use those clouds. Hybrid clouds made up of 2 or more cloud types. For example, part custom, part public. And then at the bottom there it says built to meet, or custom clouds. Those are built to meet the needs of specific industries. So whatever businesses you're looking for, they can build you like a nice custom cloud for that, which is pretty cool. All right. Technology trends at home. Okay. Again, these slides a little old, but this is essentially how it is. Being able to have access to things at home, like your Ring cameras, those little Google Nests to change your appliances, smart refrigerators. Hey, my milk is running low. You need to run to the store. Okay, cool. I'll go to the store and grab milk. Those type of things, right? Smart home technology is a growing trend for those allows technology to be integrated into the everyday appliances. Ovens might know what time to cook your meal, things of that nature. Any way we can be connected, right? Any way we can be connected typically uses that cloud, right? Being able to have access, right? I go back to the Ring cameras, right? Somebody's walking by your front door, right? You have an alert, right? Being able to access that information is being stored in the cloud. So if you are in a different state, you can hop on your phone, that data gets recorded to the cloud, you have access to it, there's that availability, you can actually see that information, right? Pretty cool. Power line networking can be allow devices to connect local area networks with data cables and wireless communications are not an option, right? Using the power line, being able to send those ones and zeros through there to get that data to move through. Using a standard power line adapter devices can connect to local networks wherever their electrical outlet can be. Power line networking is especially useful when wireless access points cannot reach devices in a home. Wireless broadband, in addition to DSL, more commonly found in rural areas. Like I told you, that's probably what I saw in Utah, right? They're using maybe like a wireless broadband to get to that information so they can get their information. Wireless broadband is another solution that can be used for small office businesses and antennas installed outside the house so they can so that data can be sent back and forth. Now, network security, right? This is huge. This is huge. I know cybersecurity is big right now. My personal opinion, cybersecurity has always been here. It's just more prevalent now because big businesses are getting hit, and there's more ways for people to connect to the internet, so they're trying to find more people to help protect their data, right? This is where network security administration comes in. So this class, things you learn in this class are very, very applicable to cybersecurity. Being able to secure that data as it leaves out of those businesses, right? Making sure there's no issues. So network security is an integral part of networking regardless of the size of the network. That is very true. The network security that is implemented must take into account the environment and securing the data, right? But still allowing the quality of service that's expected for the network, right? So we want to make sure that if, you know, Manager Johnny is up on the 3rd floor, you know, we want to make sure that he has access to everything, but we don't essentially want to just lock him out of everything, right? Quality of service. We want to make sure that he's still good to get to the data he needs to, kind of the principle of least privilege, per se, right? And then we have threat vectors, might be external, internal, right? There might be some internal people doing bad things, might be hacking things, looking things that they're not supposed to see, and then we may have external people doing those items. External threats, as you see here, won't get into all these, denial of service, spyware, adware, Trojan horses, viruses, all that good stuff. Internal threats, people that are trying to look at things internally, malicious employees trying to cause bad items, things of that nature, right? So all comes in network security. Now, I really like this one, right? This is the layers. Like security must be implemented in multiple layers, right? Now, why is that important? Why, if I'm building a house, right, and I want to make sure that my house is secure, would I want to put one lock on one door? If I have 4 different doors to get into my house, if I have the back door, if I have the side garage, the front door, would I want to just put one lock on the door? And the answer to that question is absolutely no, right? We don't want to do that. We want to make sure we have multiple locks, i.e. multiple layers, right? Because we don't want them to be able to get into it, right? So we may put a couple firewalls in on the network, right? We may put some things on a computer to make sure that, nobody is clicking on items or any different viruses will get installed and things of that nature, right? We want to protect everything inside of our network, right? Okay, larger solutions, they use IPS, virtual private networks, VPNs. We're seeing a lot of that now. People using virtual private networks, things of that nature. Now, the IT professional. Now, this is pretty cool. Now, this is kind of what this is kind of the why this class exists, right? I've been coaching high school football for over 20 years. I'm a sports guy, played football at San Jose State University, and every time I go through drills and all that, I like to understand why we're doing things. Same thing I put my students through at the high school level. Why are we doing these things, right? So with this class, this is the why, right? It's because of these certifications with Cisco, right? Essentially, it's probably why you're taking this class, because it'll help you earn a pathway to get to these certifications, right? Very, very powerful certs, right? The CCNA, Cisco Certified Specialist, CCNP, all that good stuff, right? These certs are so powerful. Okay, I will tell you that I have a couple friends that moved out of the state. Actually, they moved out of the country, and they had these certs, right? And they went to their local businesses in the country that they're at, and the company, they recognize this certification because it's all the same language, right? It's all the same configuring and things of that nature when it comes to the CCNA. Very similar to the CompTIA. CompTIA is a very, very good certification as well. And I currently have an A+, all that good stuff. So having these certifications is what this class is about, kind of giving you that pathway towards that. There are a lot of jobs, a lot of employment out there, a lot of big businesses that are looking to hire, okay? So there's a lot of different ways. You can go on netacad.com, you click on careers, that'll kind of help you pave that way to getting those certifications, okay? So that's pretty much it. Make sure you do those modules. This is the end of module 1, okay? If you haven't gotten Cisco Packet Tracer yet, Make sure you download Cisco Packet Tracer, okay? And then that is it, all right? So you guys have a great day and enjoy.